Good morning, children. Welcome back to mathematics class. How are you all? Hope you all are taking a good care of yourself. So let us start today's class. Children, today I am going to begin with a new chapter. Fine. So let us start the class. This is class 10th, subject mathematics, chapter number 10, circles, lecture number 1. And content I am going to cover from NCERT. Children, approximately in 5 lectures I am going to finish this chapter. Fine, children? The topics which I am going to cover in today's the very first lecture of chapter number 10, circle, they are: number 1, definition of circle; number 2, all the important terms which are related to the circle like radius, diameter, chord, arc, circumference of the circle, semicircle, segment of the circle, whether it is minor segment or major segment, sector of the circle, whether it is minor sector or major sector, and secant. Fine, children? After that, I will explain you the tangent to a circle. Fine? Then I will be taking theorem 10.1, and after that I am going to take sums of exercise 10.1, in which the usage of this theorem is there. Fine. We are going to use this theorem while solving the questions of exercise 10.1. And then, children, our last topic will be number of tangents from a point on the circle. Understood, children? So these very topics we are going to cover in today's lecture. Children, you all know very well the definition of circle as well as all the terms which are related to circle. So let us recall them. First of all, our first topic is, what do you mean by circle? Children, here you can see a big circle. Fine. So what will be its definition? A circle is a collection of all the points in a plane which are at a constant distance from a fixed point, and this fixed point is known as the center of the circle, and this constant distance is known as the radius of the circle. Correct, students? I repeat, a circle is a collection of all the points in a plane which are at a constant distance from a fixed point, and that fixed point is known as the center of the circle. Fine, children? And those constant distances are basically known as the radii of the circle. Correct, students? Here you can see OA, OA dash, OR dash, OR, they all are the radii of the circle. Correct, children? Now I am going to switch to the next point, or I should say the next term which is related to circle, that is diameter of a circle. Diameter of a circle is basically a line segment whose both the end points lie on the circumference, or I should say on the boundary of a circle. Fine, children? And this line segment always pass through the center also. Here you can see A dash is a diameter, R dash is also a diameter. So diameter is a line segment whose both the endpoints lie on the circumference of the circle, and it passes through the center also. Correct, children? If somebody asks you what will be the definition of radius, then what will you say? Radius is a line segment whose one end point lie on the circumference, or I should say the boundary of the circle, and another end point is the center itself. Correct, students? Now the next term is, what do you mean by chord? Here, children, you can see that PQ is a chord. You can see MN is also a chord. So while looking the picture of a chord in a circle, you can easily define it. So chord is also a line segment whose both the end points lie on the circumference of the circle, but it does not pass through the center point. So definitely there is a relation between diameter and a chord. We can say that diameter is the longest chord of the circle. Why it is longest chord? Because it is going to be passed through the center point. And as for chord, both the end point lie on the circumference of the circle in the same manner. The end point of the line segment, which is actually a diameter, they also lie on the circumference of the circle, but it passes through the center also. Fine. But for chord does not pass through the center, but it's both the end point lie on the circumference of the circle. Correct, children? So you can say that this is basically the difference between diameter and a chord. That chord does not pass through the center, but diameter passes through the center. Now the next point is, what do you mean by arc? A continuous piece of a circle is known as arc. Here in this diagram, children, you can see A, this is RBA is an arc. Just look at this arc also. MR-N, this complete. This is also a continuous piece of a circle without any break. So this is also an arc, and this is the symbol of arc. Now children, arcs are of basically two types. As I have taken so many points on this circle, so it would be better if I am going to draw one small circle for you and I am going to explain you this particular point, that is minor arc and major arc. Children, here you can see this PMQ, this part. This is a continuous piece of a circle. So this PMQ is minor arc. But if I am going to talk about PRQ, this is major arc, as it is clear from the diagram itself. Fine, children? So we can say that smaller part is called as the minor arc and this larger part is called major arc. Correct, children? Now next comes circumference of a circle. Circumference of a circle is nothing but the boundary of the circle. Or we can say the length of the complete circle is called the circumference of the circle. Correct, students? Next is semicircle. What do you mean by semicircle? A diameter of a circle divides it in two equal parts. One part is this one, below one, and another one is the top part, which are basically these two equal arcs. So each of these arcs are known as semicircles. Correct, children? Now next comes segment of a circle. So the region between the chord and either of its arc is known as segment. Children, here you can see that MR-N is the minor arc, and this complete M, R and N, this starts from here, M, R and N, this is complete major arc. So what should I say about the minor segment? Minor segment is basically the region which is bounded by the minor arc and the chord. Correct, children? You can understand through this smaller circle also very easily. Just look at here. This is PMQ is the smaller arc and PRQ is the major arc. So this PQ is a chord. So this is the region basically which is bounded by the chord and the minor arc. So this portion is known as minor segment. But if I talk about this portion, this is again the region which is bounded by the chord and the major arc. So definitely it will be known as major segment. Understood, children? The same concept I can explain you while taking this very chord also. If I am going to talk about chord PQ, here you can see that this part is minor segment, and what about rest part? Rest complete part will be known as major segment. So segment is the region which is between a chord and either of the two arcs. Either it will be minor arc or it will be complete major arc. Correct, children? Now let us switch to the next point, that is, what do you mean by sector of a circle? Sector of a circle is basically the region between two radii and an arc. Again, it depends, children, if you are going to take minor arc. So definitely the region between two radii and the minor arc will be known as minor sector. But if I am going to talk about the region which is between two radii, this radii, one OR and another one is OA, and the major arc, complete major arc, it will start from R dash and then A, then that complete region will be known as major sector. Let us understand while taking this smaller circle. You will better understand through here. This is a smaller circle. You can see here O is the center point. So definitely OP and OQ, they both are radii. So this is that region which is bounded by two radii and this arc. What kind of arc is this? Of course, this is minor arc. So this will be known as sector of the circle. But what kind of circle? This is minor sector. Okay. Minor sector of the circle it will be known as. Now, let us talk about this complete part now. Again, the area which is bounded by two radii, one radius is OP, another is OQ, and the major arc. This is complete major arc. You can give one name here also. Let it be R point. So, this complete region is known as major sector of the circle. Correct, children? So children, the area bounded by two radii and minor arc is known as minor sector of the circle. It will be OPQO, correct? And if I talk about the major sector of the circle, then you will say that the region bounded by two radii and the major arc. Fine. So how will you name it? It will be O, P, R, Q, and ultimately you will be reaching on O. So this complete part is known as major sector of the circle. Clear, children? Now children, here is our next topic, that is tangent to a circle. In this topic, we will discuss the relation between a circle and a line which are given in a plane. Correct, children? So for that we are going to consider a line, let it be AB, and of course a circle. So there will be basically three possible cases according to the position of the line AB with respect to the circle. Fine, these very cases I am going to discuss. So let us discuss case number 1. When there is no common point between a circle and a line AB. Fine. This is case number 1. As I have told you that when we are going to discuss about the tangent to a circle, it means we are going to deal with a line and a circle. So what is case number 1? When there is no common point between the line and the circle. Then what will you call to such kind of lines? You will call it non-intersecting line because it is not going to intersect a circle at any point. Correct, students? So here we will say that line AB is said to be non-intersecting line with respect to a circle. Correct, children? Now we are going to switch to case number 2. When there are two common points P and Q between a circle and a line AB. Then in this case, children, AB intersect the circle in 2 points. Here you can see that the complete line AB is going to intersect at 2 points, that is P and Q. So in this case, this line AB will be known as secant of the circle. Understood, children? So if somebody asks you, what do you mean by secant of the circle? Then what will you say? A line which intersect the circle at 2 points is known as secant of the circle. Fine, children? Now let us switch to case number 3. When there is only one common point between a circle and a line AB. Here you can see this is a circle, this is line AB, and this line AB is going to intersect the circle exactly at 1 point. And this point P is basically known as the point of contact. Because there is a contact, here you can see at point P, there is a contact between the line and a circle. So here this complete line AB will be known as tangent to a circle at point P, and this point P is known as point of contact. Understood, children? So children, here one question strikes in my mind. Define tangent. So the word tangent has been derived from the Latin word tangere, which means to touch. Correct, children? So if somebody asks you, what do you mean by tangent to a circle? Then you will say that tangent to a circle is basically the line which intersects or touches the circle exactly at one point. And that common point of the tangent and the circle is known as the point of contact. Fine, children, I have just explained you this right now. Now here comes our next topic. Number of tangents from a point on a circle. So this is our next topic, children, which I am going to explain you. Basically, how many tangents can be drawn from a point? That depends on the position of the point also. For example, in case number 1, this is the same case actually. When the point P lies on the circle itself, here you can see that the point P is lying on the circle itself. Then children, can you tell me how many tangents can be drawn in this case? Correct. Only one tangent can be drawn. Fine, students. So if a point P lies on the circle, then there is only one and only one line passing through the point P, which touches the circle in one point only. So what can we say? That there is only and only one tangent which is passing through the center, of course, and that point where it is going to be touch the circle, that very point is known as the point of contact. I have just explained you about it. Now let us switch to case number 2. If the point P lies outside the circle, then how many tangents can be drawn? Then in that case, children, we can draw maximum 2 tangents. Here you can see that PQ and PR are 2 tangents which I have drawn, in which case when point P lies somewhere outside the circle. Let us discuss case number 3. Suppose point P lie inside the circle. Then children, you know that tangent is basically that line which touches the circle exactly at one point. And if I am going to draw millions of lines passing through this point P, then there will be no tangent drawn. Why? Because these very line segments are not going to touch the circle exactly at one point. Correct, children? Here you can see that if a line segment is going to be passed through point P, then definitely it is going to touch the circle at 2 points. But for tangent, for a line segment to be a tangent, it must pass or it must intersect the circle exactly at 1 point. Correct, children? So here one more question can be asked. What is the difference between tangent and secant? What is the difference between them? So you will say that tangent is a line which intersects the circle exactly at 1 point. Okay. And that point is basically known as the point of contact. But if I talk about the secant, then secant is a line which intersects the circle at 2 points. Correct, children? Now children, I am going to begin with theorem 10.1. Please be alert. This is very important theorem. In fact, the use of this theorem we are going to do while solving so many questions of circles. Fine, children? So what is the statement of theorem 10.1 from NCERT? The tangent at any point of a circle is perpendicular. This is the sign of perpendicular. You can see to the radius through the point of contact. What is the statement saying of the theorem? That tangent at any point of a circle is perpendicular to the radius through the point of contact. So let us start this theorem. So before I switch to given and to prove, let me explain you what is basically the statement of this theorem. Through this theorem, we have to prove that tangent at any point of a circle. Here I have taken a point P and one tangent is drawn. So at any point of the circle, whenever a tangent is drawn, that tangent is basically perpendicular to the radius at the point of contact. This we have to prove. Correct, children? So let us start. What is given? A circle with the center O. Here you can see a circle with center O and a tangent AB at a point P of the circle. Here you can see that there is a line AB drawn. Okay, and where this line is going to intersect the circle? It is going to intersect the circle at point P. So what do we call this point P? Correct. This will be known as point of contact. Okay. So what we have to prove? We have to prove that OP is perpendicular to AB. We are going to prove that radius is perpendicular to the tangent. This proof beta we are going to use in most of the questions. Okay, so you please understand this theorem very carefully. So one construction I have done to prove this theorem. Take a point Q. Here I have taken a point Q other than P. One point was there, P, on the line AB. One more point I have taken other than P, that is point Q. Okay, on the tangent AB, and then after that I am going to join this point Q to the center point. So I have got a line segment, that is OQ. Correct, children? So now its proof is, here Q is a point. Children, you can see that there is a point Q on the tangent, that is AB, other than the point of contact, which is P. And here you can see that Q is lying outside the circle. Correct? Children, think, if suppose at this place, suppose here Q is lying right now. Suppose in place of this, Q is going to lie somewhere inside the circle. Then in that case, AB will not be the tangent, because Q point will definitely lie on the line segment AB. So in that case, AB will become the secant of the circle. Please have a look on this diagram. Here I have just told you that I have taken a point Q. This is that very point Q which is going to lie on the line segment AB. Fine. On the line AB. If this point is going to lie on AB, okay, and Q point is lying inside the circle, then definitely this AB will become the secant of the circle. Correct? And secant, I told you, secant is basically that line which intersect the circle at 2 points, at A as well as at B. In which case, when Q point lies inside the circle. Are you getting me? You understand this point once again. Children, here AB is a tangent, correct? And P is point of contact. So at place of this, one is point of contact. Other than this point, I have taken one more point Q, which is basically outside the circle. Suppose if it is not outside the circle, here I have taken it inside the circle, then definitely AB will become the secant of the circle. Okay, but what is given in the question? That AB is a tangent to the circle. Correct, children? So this is compulsory that we have to take point Q outside the circle only. Because if we are going to take it inside the circle, so definitely AB will become the secant of the circle. Correct, children? So here is the proof. Now hopefully you will better understand after understanding that point. Here Q is a point on the tangent AB other than the point of contact P. Here it is. Other than point of contact P. Q lies outside the circle. It is lying outside the circle. Okay. As I have explained you, if point Q lies inside the circle, then AB will not remain a tangent. It will become a secant. Correct? So it will not be a tangent to the circle. Now, let OQ intersect the circle at point R. Here you have seen that I have joined O with point Q. I have just considered that this OQ is basically going to intersect the circle at point R. Correct, children? So can you tell me what is the relation between OP and OR? Good. They both are radii of the circle. So we can say that OP is equal to OR Why? Because they both are radii of the circle. Now children, please look at here. How can I write OQ? Can I write OQ as OR plus RQ? Because OQ is made while adding the length OR and RQ. So here I have written OQ is equal to OR plus RQ. So it implies 2. Children, here you can see that OQ is basically the length which is bigger than OP. That is actually the radius of the circle. OQ is greater than OP. Please look. As OQ is the summation of OR and RQ. So what can I say? That OQ is greater than OR. Because OQ is made when I added RQ in OR. Okay. So I can say that OQ is greater than OR. And OR and OP both are equal because they both are radii of the circle. So can I say that OQ is greater than OP as well? So thus OP is shorter than any other segment joining the point O to any point on AB. Correct children? Have a look. Here you can see. Suppose children, at place of Q, if I am going to take millions of points, here I have taken Q dash, here I have taken R dash, here I have taken S dash, here I have taken T, U, V. If you are going to take millions of points over here, in each and every case, OP will remain the shortest distance. Correct children? But make sure those points lie outside the circle. Okay. So here it is written. Thus OP is shorter than any other segment joining which point? Center point, that is O, to any point on the line segment, or I should say on the line AB. So also we know that shortest distance between a point and a line is always perpendicular distance from that point to the line. This we know very well. Okay, so what can we say? That OP is perpendicular on AB. Look, this OP is perpendicular on AB. Correct children? And this we wanted to prove basically that radius is perpendicular to the tangent at the point of contact. This last line, which is actually a true statement, that the shortest distance between a point and a line is perpendicular distance from that point to the line, that I am going to prove you. Have a look. For example, here I have taken a point P and this is that very line segment. Children, here you can see that this is the distance. This is basically the shortest distance between this point and a point which is going to lie on the line segment. But if I am going to take millions of points over here, then they always be bigger than this particular length. Correct children? So this is a true statement that a shortest distance between a point and a line is perpendicular distance from the point to the line. That is actually the perpendicular distance always. So what can we say? That OP is perpendicular to AB. OP is nothing but the radius and AB is nothing but the tangent. So we have proved that radius is perpendicular to the tangent at the point of contact. Clear children? Now I am going to take one question from exercise 10.1, which I found a little difficult for you. Otherwise all are very simple. So rest of the questions you are going to do yourself. Have a look. This is question number 3. A tangent PQ at a point P. At a point P, through this you can judge that P is nothing but a point of contact of a circle of radius 5 cm meets a line through the center O at a point Q, so that OQ is equal to 12 cm. Then we have to find the length PQ. Correct children? So let us draw its diagram. A tangent PQ at a point P. Here first of all I have drawn a circle. Then this is a tangent PQ at point P, means point P is known as the point of contact of radius 5 cm. Okay. It meets a line through the center. At a point Q, there is some more point taken Q. Okay. So it is going to meet the center point such that OQ is equal to 12 cm. Fine children? Okay. Basically this was complete a tangent. Complete tangent it was PQ. Here you can see that OP is radius. Q is that very point such that OQ must be equal to 12 cm and this is radius given. We have to basically calculate the length of the tangent, means we have to calculate PQ. Fine children. So let us start. Here you can see that PQ is a tangent which touches the circle at one point, that is point P, and this point P is known as point of contact. Here OP is equal to 5 centimeter and OQ, this is one point Q, and the distance between O and Q, that is OQ, is equal to 12 centimeter. We have just proved, children, in the theorem that we know that radius is always perpendicular to the tangent at the point of contact. We know that radius is perpendicular to the tangent at the point of contact. So what can we say? That OP is perpendicular on PQ. Look. So what has it become? It has become a right angled triangle. And the side which is opposite of 90 degree, that is known as hypotenuse. This is perpendicular because this is the shortest distance. And of course PQ will be the base. Now in this right angled triangle OPQ, I am going to apply Pythagoras theorem. What does Pythagoras theorem say? Hypotenuse square is equal to perpendicular square plus base square. That is OQ square. This is OQ is hypotenuse, you can see, and OP square, that is perpendicular square, and PQ square, that is base square. So what is OQ? This is 12 square is equal to OP is 5 square plus PQ square. Fine, this is 144, this is 25. So PQ square is equal to 144 minus 25, that is 119. So what will be PQ? It will be root 119 centimeter. Correct, children? Or if you want, you can here also write down centimeter. Here also with 5 also you can write centimeter. When you are going to go for their squares, so you will be getting centimeter square actually. Okay, children? And after finding its square root, you have got root 119 centimeter. Fine, students? So that's it for the day. Now this is the time to get mathematics homework. Please write down your maths homework. Children, whatever definitions I have just explained you related to circle and its related terms, you have to just learn all those definitions, okay? And you have to revise theorem 10.1. Please do it twice. One time in your homework notebook and one time in your practice notebook. And along with it, children, you have to do exercise 10.1 in homework notebook along with the classwork questions. Fine. Very simple questions are given. Even filling the blanks are also there. So those filling the blanks you are supposed to do in homework notebook only. Do not do them in book. Fine, children? So that's it for the day. Please like the video and do not forget to subscribe our channel. Thank you and have a nice day.